Hey there, math hoppers. In this video lesson, we will learn the three multiplication properties of exponents. So let's begin. Let's start by considering this expression where we're multiplying x cubed times x to the fourth. Remember that in an exponent or something in exponential form, there's a base, which is the only value being multiplied, and the power, which tells you how many factors of that base you are going to multiply. In order to understand this rule, let's look at what this expression would be like if we wrote it in expanded form. So if we were to write x cubed in expanded form, there would be three factors of x, or x times x times x. Likewise, x to the fourth would simply have one additional factor of x here because there's four factors of x being multiplied. This shows us that if we wanted to multiply x cubed by x to the fourth, we could simply multiply these two expressions we just created. So let's see what that would look like. X cubed times x to the fourth would in fact be three factors of x times four factors of x. And writing this answer, we can see that our base would be x because that's what's being multiplied, and our power would be 7 because there are 1, 2, 3, 4, 5, 6, 7 factors of x being multiplied. So that lends itself to showing us what this rule is. If we are multiplying two expressions in exponential form with the same base, we simply add the exponents. If we have some value x raised to the power m times some value x, same base, raised to the power n, we want to find the product, we simply add the two exponents, right? And that makes sense. If you have three factors of x times four factors of x, altogether you have 7 factors of x. The only thing you have to remember, the bases have to be the same to use this property. If you were multiplying x cubed times b to the fourth, you couldn't add the exponents. You wouldn't know which base to use, x or b. They're not the same. They're not comparable. So that wasn't too bad, right? So what that's called is the product of powers property. Don't let the name fool you. It's just called the product of powers because we are simply taking the product of two things raised to a power. And as we said before, it just involves adding those exponents. So let's look at a few examples, make sure we really got this. X to the fifth times x to the fourth. Think about it written out in expanded form. You would have 5 factors of x times 4 factors of x. Altogether, you would have 9 factors of x, x to the ninth. If you had b cubed times b to the ninth, same thing. You would have b to the 3 plus 9 or b to the 12th power. Okay? That's the first property. Moving on to the second property, this is when we raise a power to a power. Consider the expression x squared cubed. So we already have a power in the fact that we have x squared. And we're taking this expression and raising it to another power, 3. So x squared cubed. Remember when we learned exponents, we learned that they involved multiplication. This says I have 3 groups of x squared. Well, let's see what this looks like in expanded form. We know that x squared is x times x. Therefore, x squared cubed really means we have 3 groups of x times x. So written out, let's see the 3 groups. 3 groups of x times x looks like this. The answer would then be x, because that's the base, that's what's being multiplied, to the 6th power. That's how many factors of x there are. It does make sense if you think of exponents as dealing with multiplication that our rule for raising a power to a power involved multiplication. When we took x squared cubed, we had 3 groups of 2 x's. So we got x to the 2 times 3. That in fact is what the rule states. If you have some value x raised to the m power and you raise that to the n power, you find the product by multiplying those exponents. So let's formalize this a little bit. This was the power of a power rule. Simply because we took a power, raised it to another power, we found out that when we do that, we just multiply our powers. Again, let's look at a few and make sure we have it. X to the 5th squared. Well, that would mean 2 groups of 5 factors of x. X to the 5 times 2 would be x to the 10th. How about 2 cubed squared? This means we have 2 groups of 3 factors of 2. So we have 2 to the 3 times 2, which is 2 to the 6th. Now notice this is an actual number, right? Here we had x, so we left it alone. Here we have 2. We can multiply 2 to the 6th out. we would say 2 times 2 times 2 times 2 times 2 times one more 2. And we would get 64. So if you have a base that's actually a number, most likely you're going to be asked to multiply that out. Now let's raise a product to a power. This is going to look very similar to what we did on the previous screen. However, instead of x squared cubed, we have 2x squared cubed. So how is this different than what we just saw? Well, there's a 2 there. That 2 is an additional factor. You see how we have 2 times x squared? That means we have 2 factors being raised to the third power. Think of 2x squared as 2 times x squared, and all of that is cubed. When you have two things within a parenthesis being raised to a power, that power really has to go to both things in there. This is 2 cubed times x squared cubed. 2 cubed is easy enough. That's going to be 2 times 2 times 2, which is 8. And for x squared cubed, we will use the power of a power rule like we just saw. So we will wind up with 8 times x to the 2 times 3 power, or 8 times x to the 6th power. So this is less of a new rule and more of a, please don't forget when there's something else in the parenthesis, raise that to a power 2. Now this does get noted in textbooks as a third multiplication property or a third multiplication rule. So we have it here in formal form. We will formalize it on the next screen. It's really just reminding you to take everything within that parenthesis and raise it to the power stated. Again, that was the power of a product property. Don't let the names confuse you. It's simply called that because we have a product that we are raising to a power. So we have the power of a product property. Let's look at a few. We have 4n to the 4th, all raised to the third power. 2 factors are being raised to the third power. 4 is being raised to the third power, n to the 4th is being raised to the third power. Therefore, we get 4 cubed times n to the 4 times 3, or 64 n to the 12th. One more. All right, so we have negative 2xy to the 5th. So 3 factors. Negative 2 is within the parentheses. X is within the parentheses, and y is within the parentheses. They are all being multiplied, so that is 3 factors being raised to the 5th power. We break it out, it looks like this. Negative 2 to the 5th times x to the 5th times y to the 5th. Remember when you're multiplying, if you have an odd number of negatives, you have a negative product. So negative 2 to the 5th is going to be negative. It's going to be negative 32 to be exact. So you get negative 32 times x to the 5th times y to the 5th. Those are the 3 properties. Let's do a few just to make sure we have them all. So let's say we had n cubed times n to the 8th. We are multiplying 2 expressions raised to a power. So we have 3 factors of n times 8 factors of n. We have n to the 3 plus 8, or n to the 11th. All right, next one, we have the quantity negative 2 cubed, and then this entire thing cubed. So let's first use the power of a power rule before we freak out about the negative 2. So this can be rewritten as negative 2 to the 3 times 3, which is negative 2 to the 9th. Now we have an odd number of negatives. We are multiplying 9 factors of negative 2, and 9 is an odd number. We get negative 512. Next one, we have 4x times x squared times x cubed. This one does not look very difficult. What happens here, though, is people forget that x is x to the 1st power. And so they forget to add that when they solve this problem. This really is 4 times x to the 1 plus 2 plus 3 power, or 4x to the 6th. All right, the last one is the ugliest, but it is the last one. If we have 5n squared cubed times 2n cubed squared, within this expression we have 2 factors being raised to the 3rd power. We have 5 being raised to the 3rd power and n squared being raised to the 3rd power. Then we have 2 being raised to the 2nd power, n cubed being raised to the 2nd power. So let's write this all out and try to make some sense of it. So again, I kept the things in purple from the first expression and things in blue from the second. 5 cubed, that's very easy. We took that right here, 5 being raised to the third power. N squared cubed is n to the sixth. 2 squared came from there. N to the sixth came from n to the third raised to the second power. Let's put this all together now and see what we get. We've got 125 from 5 cubed, 4 from 2 squared, and n to the 12th from n to the 6th times n to the 6th. Let's show you how I got there. 5 cubed times 2 squared, that's the 125 times 4. N to the 6th times n to the 6th, that's my n to the 12th. I can't leave the answer like this because I have 125 times 4. I have to go ahead and simplify that and write 500 n to the 12th power. And that is our final answer. If you have any questions, if you're doing your homework and you see one that looks more complicated than anything we've seen, you should be subscribed to our YouTube channel. Go ahead and submit your homework problems there. We'll make a custom video solution for you. And until next time, Math Hoppers, take it easy.